Hello, Math 1030. This is lesson 10A. We're going to be talking about some geometry concepts. 10B also is some geometry concepts. So a couple lessons on some geometry. Coming up soon after 10B is review time and test. Getting close to the end here. All right, so first of all, just really quick reminder about angles. Um, Anytime we have the intersection of two lines or two line segments, it forms an angle. The point of intersection is called the vertex. You could have a right angle that measures 90 degrees. Anything less than that is called an acute angle. Straight angle is 180 degrees, and an obtuse angle is something that is between 90 and 180. We're going to use angles a bit right now, and then also a bit more in lesson 10B. So this first example from lesson 10A is that we want to find the degree measure right here, this angle. We want to know how big it is for this portion of the circle. And we know that the shaded portion of the circle is 7/12 of the circle. So we're going to calculate that angle by taking that fraction, 7/12, and multiplying it by the angle measure of a full circle. MEASURE, angle measure of a full circle is, wow, good handwriting, 360 degrees. So 7/12 multiplied by 360 will give us our angle measure. 7/12 of the circle multiplied by the full angle measure is 210 degrees. And that is it. All right, next geometry topic has to do with two-dimensional shapes. So circles are going to be one of the major focuses of your homework questions. Circle is just the set of all points that are located the same distance from a point that is called the center, and that distance between the center and the edge is called the radius. The diameter would be twice the radius. For our two-dimensional shapes, the outside edge of the shape is called the perimeter. For a circle, we call that perimeter circumference. And the area is the amount of space inside the boundary of a shape. So we've got a formula sheet here that has some different formulas. For the perimeter, we will all mostly be using this for circles. So its circumference is 2 pi times the radius. And then area of a circle is pi r squared. I think on your homework you'll have to use a rectangle area. I can't remember. They used to have some triangles, but I think they might have been taken off. I think most of it is circles. So let me know if you have questions when you get to doing it, if I've left something out. I tried not to, but I may have. For circles, it's going to ask you to find the circumference and the area of the circles. Please be extra mindful that on some of the examples it will give you the radius, and on other examples it will give you the diameter. Oftentimes the diameter ones end up being incorrect because of just going too fast. So remember, if it's a diameter, it's a little different. So for this first circle, we have a radius of 6. So the circumference would be 2 pi times the radius, which is 2 pi times 6. On this little calculator, it will usually give you your answer in terms of pi. So if you use the converting button right there, it'll give you the decimal. So our circumference is 37.7. And it's going to definitely ask you the units. For circumference, that is a linear measurement. In other words, you could measure it with like a tape measure. So that would be in inches or maybe feet or maybe meters or whatever measurement they're giving you. For area, that would be squared. It's two-dimensional, so we would have maybe either inches squared or square feet, or it may have like the subscript squared, something like that. So for circumference, it's just the measurement. For area, it's going to be squared. So this would be 37.7 inches. Area is pi times the radius squared. So for this circle, that'll be pi times 6 squared, which is in decimal 113.1, and again, that would be square inches. I think in my math lab it might use words instead of the squared symbol, but I can't remember. I literally looked at it like 2 seconds ago and I still can't remember. Good brain. All right, if your circle gives you a diameter, get the radius half of that diameter. So if my diameter is 18, my radius is 9, and I'm going to use that in my formulas. 2 pi times 9 would give us the circumference. That will be 56.5, and that is also inches. For the area of this second circle, it's pi times radius squared, which is in decimals 254.5 square inches. Again, biggest thing to watch for is watch out for diameters. Cut it in half when you put it in the formulas. Okay, three-dimensional geometry. When we talk about three-dimensional shapes, we are usually talking about their surface area or volume. I don't think that you'll have to do any surface area problems. I think mainly what you're going to see is volume of a rectangular prism and volume of a cylinder. So those are the two to focus on. First one is a water canal, has a rectangular cross section so that it is 3 meters wide and 2 meters deep. We want to know how much water would be contained in a 30-meter length of the canal. So it's just a rectangular prism, I guess. So the volume is just length times width times height. So 30 times 2 times 3 is 180. Each of those was in meters, so this is meters cubed or cubic meters. My math lab, I'm sure, will ask you the units. It might be in words instead of with a power. I think it's multiple choice for the units. All right, second question, and this similar one to this on the homework, just be really mindful of. It gives you a percentage, but I think in both cases you don't directly use that percentage. Our question is, how much water does this segment of the canal hold after 60% of the water has evaporated? So 60% is gone. We want to know how much water is left. Well, if 60% evaporated, then how much is left is 100 minus 60%, which is 40% left. Oh, that's too small of a zero. Good handwriting. 40% left. So to calculate how much water is left, I mean, we know it's 40%, so we just take that percentage and we multiply it by 180 cubic meters. We only have 40% left, so we multiply it. 40% of 180 is 72 cubic meters. So again, a lot of times you don't use that percentage directly. You use, its complement, I guess. All right, which holds more, an oil drum with a radius of 2 feet and a height of 3 feet, or an oil drum with a radius of 3 feet and a height of 2 feet? Okay, so we're going to calculate the volume of each of these. Our volume formula for a cylinder is that it is a circle, pi r squared, multiplied by a height. So for this first one, it is pi times the radius squared times by 3. So pi times 2 squared times 3 is 37.7, and that would be feet to the third power, or cubic feet. For our other cylinder, it would be pi times 3 squared times 2, because the radius is 3 this time, and the height is 2. So this is a volume of 56.5. So if our question is which one holds more, the oil drum with the radius of 3 and the height of 2 holds more. I think in my math lab it will make you type in both of those volumes and then choose which one holds more. All right. Last thing, some scaling laws. Now this is just to warn you ahead of time. I don't know, I haven't looked at this year's test, but this idea has come up on tests in the past, and it is a very commonly missed test question in the past. So I don't know if it comes up this year or not, but I would pay attention. This is a pretty basic concept, so just don't overthink it. And don't blow it off either, because it's commonly missed. So when we talk about scaling something, we're talking about keeping the same shape but making it either larger or smaller in size. So for example, if I have like a little block, if I make it twice this, if I scale each side by a factor of 2 so that it's twice as wide, twice as deep, and twice as high, we can talk about how that changes its area, surface area, and how that changes its volume. Length is a one-dimensional thing. It just has length. So if I have something that's one-dimensional and I scale it by a scale factor of 3, I make it 3 times as long, whatever the length is, it would just be that times by the scale factor. Sorry. I know how to tell my phone to stop ringing. I'm so good at technology. All right, so like length, you just use the scale factor. But if you're talking about area, like if I had maybe a two-dimensional square, the area of that square doesn't just get timesed by scale factor 3. If this is 7 times, I'm doing a really good job of explaining this, I can tell. I'm so sorry. If I make each of the sides 3 times as long, if I make this one 21 and this one 21, the area did not get times by 3. The original area was 49, but the new area would be 21 times 21, which is 441. It's not getting multiplied by 3. It's getting multiplied by 3 in each direction, so it's getting multiplied by 3 squared. For area, you have to square the scale factor. And you could extend that idea to volumes as well. For example, if this cube had a side length of 3, its volume would be 27. Well, if I double it, it's now 6 times 6 times 6. I doubled it, so scale factor 2. 6 times 6 times 6 is 216. So the volume did not get timesed by 2. The volume got timesed by 2 to the third power. The height got doubled, the width got doubled, the length got doubled. It got doubled in 3 dimensions, so 27 times 8 is what gives me 216. So long story short, probably the world's most confusing explanation. So sorry. If you are trying to decide what happens to a two-dimensional or three-dimensional thing, you have to use a power on the scale factor. So suppose that magically your size is suddenly tripled. Your height gets tripled, your width gets tripled, and your depth gets tripled. So old you and new you. Wow. So good at this. Tripled. You were 5 feet tall, just like me, and now you're 15 feet tall. Okay, so by what factor has your waist size increased? Well, a waist size is just a linear dimension. It's just, you could wrap a string around and measure how long that string is. We got tripled, so our scale factor is 3. Well, if our scale factor is 3 and we want to talk about our waist size has also increased by a factor of 3. It's just a linear measurement. Second part, how much more material would be required for your clothes? Well, think about material, and I guess it's kind of hard unless you are sewing or something, but material you can lay flat on a table. Material is two-dimensional. Clothing is three-dimensional, but it's constructed from two-dimensional materials. So if you were talking about like building your clothes or, constructing your clothing, we're talking about a two-dimensional thing, so it's going to be the scale factor squared. So you're going to need 9 times as much material to make your clothing. Two-dimensional means use a second power. By what factor has your weight changed? Well, weight is a product of volume, which is three-dimensional. So our scale factor is 3. We need to raise that to the third power because it's three-dimensional. So we're not going to weigh 3 times as much. We're going to weigh 27 times as much because volume and weight are three-dimensional things. So just make sure you're remembering to use your powers when you are talking about two or three-dimensional objects and you're scaling them. All right, so that is it. Let me know what questions come up. I'm more than happy to help. One more lesson and then it's test review time. So let me know what questions come up. Thanks.